Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, today we are going to start with the third section of Introduction to Mixtures and the Separation with the topic Liquid-Liquid Mixture Separation, where we are going to learn two methods to separate liquid-liquid mixture. First is separating funnel, second is distillation and fractional distillation method. So friends, let's start one by one. First with separating funnel. As we are talking about liquid, we should know first the properties associated with the liquid. So what are the properties? First is it have a fixed volume, right? It is non-compressible, Third, have definite mass. Fourth, they diffuse fast. That is fast diffusion, you can say that. They are fluid. That is, they can flow easily. 6, have a fixed boiling point. They have a fixed density. So friends, if I'm talking about the mixtures, let's suppose we are talking about two mixtures, right? Let's talk about water and oil, right? So let's compare the properties of both and understand if we can separate them. They have a fixed volume, yes, both have a fixed volume. Non-compressible, yes, they both cannot be compressed. They have a definite mass, yes, both have definite mass. They diffuse, yes, both diffuse. Fluidity, yes, they can, but have a difference in fluidity, right? Yes, they have different boiling points also. Density, exactly, they have different density also. So friends, if I take a glass, this is my glass, I have mixed water and oil, and one more glass I have here mixed water and milk. Both are mixtures of two liquids. Here also two liquids. But if you see both the mixtures, you can find the difference. What is the difference? Difference is in miscibility. What do you mean by miscibility? That mixing of both liquids. Here you can find they are mixed totally. Like this is, we can say that they are into homogeneous mixtures, right? And here you can get a heterogeneous mixture. So by using this property, can we separate the mixture? Yes. For this, as there's an immiscibility and they have a different density, we can separate those mixtures who are heterogeneous and immiscible. So we can separate this mixture, right? Because we can see here water and oil both are immiscible. They are not mixing totally, and the density of both the liquids, water and oil, is different. So we can separate them by separating funnel method. So let's understand what is separating funnel method. See, I make a diagram. Here I am taking a liquid funnel where one end is outlet opening, right? We have another kind of a funnel. We have one circular where the second opening we have here. We have one receiver beaker. So how this separating funnel works? They works on the property of immiscibility and difference in density. So if the liquids are immiscible, let's take an example of any two liquids. Let's take oil and water. I have taken water and oil. So if I take a mixture in these kind of separating funnel, what happen? It will separate the mixture of two liquids into two distinct layers. The heavier liquid forms the lower layer, while the lighter one forms the upper layer. After that, if you open this stopcock and collect the lower liquid in a beaker, and now place another beaker and collect the lower, place the another beaker under the funnel and open the stopcock again, let the lighter liquid runs into it. So mixture of kerosene oil and water can be separated in this way, as the kerosene, which is the lighter than water, will form the upper layer like this. Here the heavier can get received in this beaker. As the name implies, we separate these liquid by a separating funnel by the property of liquids of different density and immiscibility, right? So this is the method, we call it separating funnel method, or you can say it is by using separating funnel we can separate two immiscible liquids of mixture. So let's understand now the conclusion, that this is the method which is used to separate immiscible liquid by using all these separating funnels. For example, I have given you oil from water, we can separate by separating funnel. So friends, what if the liquids are miscible? How will we separate them? Do you have any method to separate water and milk? Let's understand this question. As we have seen the properties of liquid, we understood that the boiling point of any liquid is fixed and is different, right? So this property we can use to separate mixtures of liquid by distillation and fractional distillation method. Now let's understand by this simple characteristics of liquid, that is boiling point, which is different of every liquid, how is it works. In the last few sessions we have a brief discussion of on the distillation method, like we had made this kind of diagram. Here is the heater, we heat from here, and we have a kind of a small funnel. We here have a coolant, and here we have a small receiver container. We have a small thermometer here kept. It's a water outlet. This condenser we call it Liebig's condenser. Here is a small opening. Water in, and in this funnel we have a mixture of liquids, right? So this is a kind of experiment, or this is a kind of apparatus we use to separate the mixture of two liquids, that is, a miscible liquids. So if the liquids in a mixture are miscible and have a different boiling point, we can separate by this method. We call it distillation, right? So here what we have done is we have taken mixture of two liquids, let's say alcohol and water. On heating this mixture in a distilling flask, the liquid with the lower boiling point changes into vapor first, and this vapor, on being cooled by the condenser, that is a Liebig condenser, collects in the receiver, and the temperature remains stationary until all the liquid with the lower boiling point distilled over. The receiver is then changed and the heating is continued so as to allow the second liquid with the higher boiling point to distill. So what will happen is, here, as we know, alcohol boils at 78.5 degrees centigrade and water boils at 100 degrees centigrade. So what will happen in this experiment? The alcohol will first get into vapor state, that is, it will boil first and collect in the receiver. Then we keep on heating until all the alcohol gets condensed and collect into the receiver beaker. After we get all the alcohol in the receiver, we change the receiver beaker and will collect the water, and we can get the separated liquids of a mixture. So what if collecting the distillate and redistillating it several times, it will take a long time. So to avoid this, we have a fractionating column, and the process is called fractional distillation. That is, what we have done is, here we keep a fractional column. This we call as fractional, or say fractionating column. Now this whole experiment is now said to be fractional distillation. What happened in this process is it involves distillation and collection of fractions or different liquid boiling at different temperatures. Right? That this method in distillation we have to carry on the heating part as long as we get separate liquids, that is distilled liquids. Now by using the fractional column we can separate all the liquids at a time. So complete separation is possible if the boiling points of the liquid differ by 30 degrees centigrade or more. That is, there is a rule, or that is a mandate. If we are using the fractional distillation first, is we have to take the temperature, that is the difference between the liquids contained in the mixture should have the difference of 30 degrees centigrade or more. Second is, what if the difference is low? For this kind of property, what we have to do is we have to fit it over the distillating flask. That is, the fractionating column is being fitted over the distillating flask. And the fractional distillation is widely used in the industry to purify and separate miscible liquids. There is very common example of crude petroleum which has been separated by fractional distillation, and to get various fractions, some of which are natural gases, naphtha, kerosene oil, diesel oil, lubricating oil, and we can also get pure alcohol by the method of fractional distillation. So in conclusion, how do we define both the methods, both interlinked methods? First is distillation. We have done it earlier also in earlier sections. It is when the liquids are miscible and have different boiling point. We can separate the mixture by distillation process. And what about the fractional distillation? It is the process which involves different liquid with different boiling point working on distillating, or you can say distillation, and collection of these liquids. right? And what are the properties we use to separate these liquid? Properties of mixture for using this method, that is a separating method. First is the liquids should be dissolved in one another, that is they should be miscible. Second, they have a difference in boiling points. As for example, we can separate water and milk. We use to separate crude petroleum. We also separate ethyl alcohol and water. So friends, I hope now you have a brief understanding of all these methods we have discussed today in this session. So now we define distillation as it is a process of converting a liquid into vapor state and subsequently condensing it again into the vapor state. And if I talk about the fractional distillation, it is a process which involves distillation and collection of fractions or different liquid boiling at different temperatures. So friends, here I end up with this session. Before ending up this whole session, let me give an activity. You have a very simple activity to do, that is you have to prepare a chart of properties required for the separation of two liquids and name the method accordingly. I hope if you have seen this video or seen this session very carefully, so you can answer this and you can prepare this chart very easily. So friends, in next session we are going to separate gas and gas mixture. That is, we'll be discussing about the methods to separate the mixtures of gases. Thank you.